Hello friends, welcome to the new short course. In this course we are going to learn Java threading, and in this very first video we will learn about thread basics, what is runnable interface, and how to override the run method. So a GUI based operating system like Windows, Mac allows you to run multiple programs in parallel. For example, you can open a PDF document of 3000 pages and search for a word. In the meantime, you may open your notepad and start typing notes in it. So if we see here, the OS is allowing two programs to run in parallel. In one exe, you are performing the search, and when search is going on, you open your notepad and you are typing some content in it. So OS allows both programs to run, and both are doing some task. One is doing the search and another one is interpreting your keystroke and displaying the character typed in the notepad. So OS allows multiple execution path. So multiple execution path means it is executing multiple exe in parallel. We call it as a process. So some people will call it as a program, and when a program is live and it is loaded, we call that as a process. When it is staying in a hard disk, we can call it as a program, but once you launch the program, it will come into memory, and that time we will call that as a process. So if you see here, Windows OS is spanning two processes. One is the PDF reader and another one is Notepad. And the user is interacting with it in two ways. One is search, and search operation is going on here, and user is typing the content. So the typed content will be shown in the notepad. By processing the keyboard input, it will start displaying the character. So this is also shown, and in the meantime search is going on in the PDF document. So if you consider that there is only one CPU, OS will perform CPU time slicing. That means it will divide the CPU time and give some time for running the or executing the instruction for PDF reader and processing the or executing the instruction for Notepad. So time slicing in the sense, suppose if there are 4 slots, it will give 2 slots for or 3 slots for PDF reader, then 3 slots for Notepad. So likewise it will slice the time, and this will be in nanoseconds or even lesser than that. So you won't see much difference. So it looks like the CPU is executing or running both the programs in parallel, or both the tasks in parallel. So the program tasks here are searching the PDF document, and another one is typing the content. So here we talked about a parallel execution in terms of programs. When a program allows multiple execution, we call that as thread. So in OS perspective, it can launch multiple program and all program can run in parallel. So we call that as a process. Process can run in parallel in multitasking operating system. So when a program or process allows multiple execution, we call it as a thread. So here if you see, Windows OS is launching Microsoft Word. We can call that as a process. Previously, we considered two different processes. One is PDF reader and another one is Notepad. Two different program is launched and they are running in memory. So one is PDF reader and another one is Notepad. So here this time we are considering only the Microsoft Word, and in Word user, let's state that the Word is a big document. Let's state it has 600 pages and the user is finding a word. So the word will be searched, and during that time user is typing some new content also in the same document. So this is allowed, and it looks like both are running in parallel. That means Windows, the Word program is searching for the specific word, and at the same time it interprets the keyboard input and shows the new content which you typed. So this can be achieved by spanning two threads. Thread 1 will do the job of finding a specific word, and thread 2 will listen for your keystroke and displays the typed content in the document. So OS can launch multiple processes, and a process can launch multiple threads to allow parallel execution. Right, so here also CPU time slicing is involved. If there are multiple programs, there are four heads. The four time slot or four time slices allocated for MS Word. Let's assume like that, and that is a time slice for other programs as well. So in that 4 time slice, what the CPU will do, it will look for the thread and allocates the time slice for one thread and another time slice for the next thread. So all comes under the CPU time slicing, and it looks like the programs or the tasks are running in parallel. So one thing here is, suppose if it takes 6 seconds without thread, when find is initiated, when user types the content, the very first character won't appear. So for example, if user is typing W after doing the find word, and since we are assuming that it takes 6 seconds, the word W won't appear here. It will wait for 6 seconds. So without thread, that's what happens. But with the thread, since these are all going in parallel because of time slice, even though it's doing some background task of search, it will, since there is a time slice, it will come back and look at the other thread also, and it knows that user typed W, and it will be shown immediately because it's in nanoseconds, right? This time slice, so you won't see any difference that you are switching between two threads. In Java, thread can be created in two ways. One is using the Runnable interface, and another one is extending from the thread class. There are two ways. So you can create your own class and implement the Runnable interface. That's one way of creating the thread. The other way is extending the thread from thread class. Extending the class from thread class. In this example, we will see how to create thread using the Runnable interface. Let's say you have a class called countryn. If you want to run a method in countryn in parallel among multiple instances, countryn should implement Runnable interface. If you see our class is countryn, it should implement the Runnable interface. So here we are considering the class as countryn, which implements the Runnable interface. So once the countryn implements the Runnable interface, it has the eligibility to run a specific method in a separate thread. The runnable interface asks you to implement a run method which will be executed on a thread. That means here you should have a thread instance. Let's call that as T. So the class contains thread T as a member. The class implementing the runnable interface should have a thread instance. So here we are having the thread instance, and it will take care of executing the run method as a threaded method. So we have to implement the run method as well. So whatever you place in the run method, that will be taken care by the thread instance here, and the thread instance will make a call to run method and execute the instruction set in that specific method in a separate thread. Say for example, we have a member here, n integer, right? We will also consider that we have 3 instances of this counter n, c1, c2, c3, right? So we will also consider that we have a run method. So if you see, these are all the instruction set. The body content or run method content will be same. So what happens? We have this thread instance, right? Once you make a call to start on the thread instance, it knows, since run is overridden here, it goes to this run method and executes the instruction thread here in a separate thread. Same goes for here. Since we have a thread instance, thread T on all these C1, C2, C3, C1, C2, C3 are counter n instance, and the thread will take care of running the run method in a separate thread. And if you see here, we are spanning 3 different threads. So this is thread 1, thread 2, and thread 3. So all we have to do is we have to make a call to start method on the thread instance. So the instance will search the run method and runs that in a separate thread. So let's see how we are overriding the runnable. How do we implement the runnable interface and override the run method? Our class name here is runnable thread, and if you see, it implements the runnable interface here. The moment it implements the runnable interface, the compiler will ask to override the run method. Here if you see, we are keeping public void run, and we marked that with a override keyword. So here we have a thread instance, right? Thread instance equal to null, and sleep millisecond we are giving a constant of 1000. So this will be in millisecond, you will see that soon. Then for this runnable thread we have a constructor. We are receiving a name and we are receiving the pass millisecond also, and we are initializing the member here, thread equal to new thread. Here we are creating the thread instance, and to this thread instance we are passing this, right? So this is nothing but a class instance which implements the runnable interface. So now our thread knows the class instance which implemented the runnable. Since it knows the class is a runnable class, that means the class that implements runnable, the instance will make a call to the run method. So we created the thread here th. In the constructor itself, we initialized it. First, we created a class instance that implements the runnable interface. Second, we gave name for the thread, so that is passed from the caller, right? String name, that's what here we are passing. Then sleep millisecond is member, and we are initializing that. So using this name, we created the thread, right? We named our thread, then pass millisecond, we are storing it internally here. All right, next we have a method called start thread, and in that start thread we are making use of our thread instance and calling the start. So once you call start, since it already have the instance of this runnable thread, this will refer the current object, right? It will, the start method will call the run. So here we have the run method, and the run method, if you see, we are looping it for 1 to 10, right? Inside we are printing a message thread.get name. So whatever name you pass, that will get printed, and it will print the I. So 1 to 10 it will get printed. Then thread.sleep, we are giving the sleep millisecond, whatever is passed here. So thread.sleep, by default it is 1000 here, but if you pass a value when creating this runnable thread, the time if we passed 500 millisecond, the thread will sleep for 500 millisecond. That means in a second we will see to system.out println, right? That's all. So since we are using the sleep, we need to do the catch, and here we are just printing the stack trace for any exception. That's all. So the stuff you have to remember is, first we are implementing the runnable interface. After that we are declaring a thread instance, and we are creating the thread instance. When we are creating the thread instance, we are giving the class that implements the runnable interface. So here we are giving this current instance because it implements runnable. Then to start the thread, we have to make a call to start. The start method will call the run method. So whatever is the body here, that will run in a separate thread, and the internal member thread th, that will run this in a separate thread. So it will run in thread context, and all this code will run in main thread context. This is main thread context, and this will be in thread context th. All right, now in the main we are creating two runnable thread instance. So thread 1 and thread 2, and if you see, the name what we are giving here is thread 1, and for second thread we are giving name as thread 2, right? And first one is 500 millisecond. That means the thread will print the system.out println with a delay of 500 millisecond, and in the second one it will do it with a delay of 700 millisecond. Finally, we are making call to thread1.start thread. We know that the member will internally make a call to thread.start. Start will run the run method. So if you see here, there are two threads that is running in a parallel, and here is the time tick. All right, if you look at here, the first number is printed here, but in the second thread there is a delay. right? Similarly, here second number is printed, third printed, and before that here 2 printed. Or if you take it this way, 3 is printed quicker, here 3 is printed with a delay, because here the sleep time is 500 millisecond, here it is 700 millisecond. So the thread 1 will finish the task first and thread 2 will finish it later. So if you see, this is thread 1 runs and ends, thread 2 runs and ends after thread 1, because here it is 500 millisecond, this one is 700 millisecond to print each number, right? And what you are seeing here is they both are running in parallel. So it's not like thread 1 runs first, after that thread 2 start and it runs second. Here if you see in the time chart, right, this is the time chart, they both are running in parallel, thread 1 as well as thread 2. Alright, so if it is a normal function called fx1 and fx2, and if you call fx1 first then fx2, then fx1 first runs, and once fx1 finishes, then in the next statement, since fx2 is there, then fx2 will run, right? That's not threaded, or we can say both belongs to single main thread, right? Here they both have separate thread 1, thread 2. Internally it has th.start, and here it has a different instance of thread.start. Start thread will make a call to start, right? And they both run in two separate threads. Okay, here we are at NetBeans IDE. We will create a new project. So we will name it as LAN Java threading. So that's the project name here we are giving. So we will delete this class. We'll create one more new class. We will call it as main entry. We will rename it as LAN Java threads. Refactor. We will rename it. So here we created a class called ex01 runnable thread, which implements the runnable interface. So this is actually the interface, runnable interface. Then, as already explained in the slide, we have a thread instance and we have default sleep milliseconds of 1000. Then we have the constructor, and in the constructor we name the thread, and we are not starting it. We are just naming the thread and we are assigning the sleep millisecond. Then here we have a separate method to start the thread. In that we make use of our thread instance th, and we are making call to th.start. Right. After that we have a run method override. In that we are printing the content, or we are printing an integer from 1 to 10. And in the main entry we will put a public void. We'll put a entry public static void main, and we will create our both thread and start it. So ex01 runnable thread, we already have the instance, and we are creating thread 1 here, thread 2 here. So here it just creates the instance of our runnable thread, which implements a runnable interface, right? After that, when you make a call to start thread, that time it will start both the thread. And if you look at here, internally we have a thread instance, right? This is the thread instance th, and when you make a call to start thread, we are making call to thread.start. I mean this is the thread instance, right? If you see, the thread implements the runnable. All right, now we will rebuild the solution and run it. Here, if you see in the main entry, there will be a main thread that executes these statements line by line. Main thread is executing the first one, main thread is executing the second one, main thread is executing the thread.start method, and it will wait for this method to return. So what happens? The method here is start thread, right? th.start, main thread will come out. In the meantime, there is a main thread as well as thread 1. Thread 1 will run this instruction. Main thread executes this and starts the second thread also. Since there are two threads now, both the thread will run this run method in parallel, and we will see that now. So here, when you look at the output, you can see thread 2, thread 1, thread 1, thread 2. They both are running in parallel, right? Let me highlight only thread 1, and if you see, it is incrementing the number, right? It is incrementing the number and printing it. So, but here you are seeing the mixture of thread 1 and thread 2. For example, thread 2 started and it printed a number 1, thread 1 printed number 1, thread 1 printed number 2, thread 2 is incrementing and printing the second number. That means they both are running in parallel and fighting for this console window and prints whatever they incremented. And here you can see thread 1 finished first. Even though thread 2 is started first here, thread 1 in between incremented the number and it finished first. Then thread 2 incremented 8, 9, 10 and it finished second. So when you run multiple times, the output may differ. So what is significant here is the thread and how it runs. Thread 1, if you see, the sleep time is, let's look at here. Thread 1, the sleep time is 500 milliseconds. That's why thread 1 is finishing first. Now let's keep thread 2's sleep second as 100. So even though thread 1 is started first, thread 2 will go quicker and finish. Now let's execute it and you will see. Right? Thread 2 finished first, and you can see how quick it is printing because we give a sleep of 100 milliseconds only for a thread 2. Then it printed 4 times by the time thread 1 printed just 2. Here it almost finished, right? After that, since there is no other thread or thread 2 already finished, thread 1 continuing with the print. So this proves that both threads are running in parallel here. That's all here in this video. Thank you for watching. Bye.